this lesson is about solving equations, and more specifically solving 1- and 2-step equations, which means you're only going to need 1 step or 2 steps to figure out what the unknown variable's value is. So to start, we're going to learn 1-step equations. Most of you can look at these equations right now and know what the answer is just by using your mental math, but we're going to practice doing this step-by-step process so that as the equations get more complicated, you'll know how to solve it instead of just trying to guess or use your mental math later on. So to start with x plus 5 equals 9, one of the best things you can do is draw a line through the equal sign, a vertical line, to keep the left side of the equation and the right side of the equation separate. Now that may seem kind of dumb, but as you get into more complicated equations, you need to keep yourself organized. A lot of students mess up because they're not organized and they forget what they have put where, and so drawing this line down the equal sign is going to keep you a little more organized. So x plus 5 equals 9. The first thing you want to do is make sure everything that is not a variable goes to one side and the variables go to another side. So you're going to have letters on one side and non-letters, or what we call constants, on the other side. So if you look at x plus 5 equals 9, the x is not by itself. It has the 5 with it. So we are going to get rid of that 5. Since it's x plus 5, to get rid of it, you do the opposite. So we are going to subtract 5. Whatever I do to the left side, I have to do to the right side because I have to keep my equation balanced at all times. You can't just add and subtract whatever you want, wherever you want. Whatever you do to one side, you have to do to the other. So the 5's go away, and I'm left with just x on the left side. I'm going to rewrite my equal sign right across that line, and then 9 minus 5 is 4. So again, a lot of you probably figured that out just by looking at it, but this is your systematic process in solving equations. So for the next one, x minus 4 equals 7. This one's a little different, but we're also going to draw this line, keep it organized. X minus 4, so that means 4 is being subtracted from x. So to get rid of it, we don't subtract 4. You do the opposite to eliminate it. So I am going to add 4 to both sides. Negative 4 plus 4 is 0, and that's the whole point. We want to eliminate it. So the 4's go away, and I'm left with x equals 7 plus 4 is 11. Now you can go ahead and check your work if you're a little worried about your answer. You can plug 11 back into x and see if 11 minus 4 really does equal 7, and it does. Okay, so that is when we have addition and subtraction in one-step equations. The next ones are going to involve multiplication and division. So draw your line, and we've got 2x equals 18. Well, the 2 is being multiplied to the x. So to get rid of the 2, it wouldn't make sense to add 2 to both sides or to subtract 2 to both sides. I want to do the opposite operation. So what is the opposite of multiplication? Division. So instead of multiplying by 2, I'm going to divide both sides by 2. What that does is this turns this 2 over 2 into a 1. So you're left with just 1x, or you could just write x, equals 18 divided by 2, 9. So one-step equation just takes 1 step to solve. Moving on to the next one, we've got x is divided by 4, and then that equals 3. So think about the opposite operation. What's happening to x? It's being divided by 4. The opposite of dividing is multiplication, so I want to divide by 4, or multiply by 4. Both sides have to be multiplied by the same thing. Again, whatever you do to the left, you have to do to the right. Now here, 4 times x divided by 4, a couple different ways you could look at it. Let me draw an arrow over here so you can see. You could look at it like 4 over 1 times x over 4, which would give you, if you multiply across, 4x over 4, which eventually, those 4 over 4 would cancel into 1, equals x. That's one way you could look at it. Another way you could look at it would be, well, 4 times x over 4. Well, I know that 4 divided by 4, before I even put those together, I know that those together make 1, so they can cross out. So if I look back up the original equation, I don't have to do anything, really, except just go ahead and cross out those 4's, because 1 is on top and 1 is on the bottom. So that leaves me with just x equals 12. Okay? So moving on, we have seen one-step equations when you have addition, subtraction, multiplication, and division. Now we're going to do that with two-step equations. So 3x minus 5 equals 10. First, draw your line to separate both sides. Okay, so this is going to require two steps. The first thing you want to do is remove any constants, any numbers that are not with the variable to the other side. So if I'm looking at 3x minus 5, I see the 3 is with the x, so I don't want to touch that yet, but I do see minus 5 all by itself. To get rid of it, do the opposite. I'm going to add 5 to both sides. Those go away, and I'm left with 3x equals 15. Now this turns into a one-step equation. 3 is being multiplied to the x, so to get rid of it, we're going to divide by 3, because that is the opposite operation. 3 over 3 is just 1, so x equals 5. Next one, 4x plus 1 equals 9. So here we have addition and then also multiplication. Again, move all the constants first. So I want to get x all by itself. I want to move everything to the other side. Since x is on the left side, I'm going to move everything to the right side. Can't move the 4 yet because it's attached to the x. You always want to move your constants first. So to get rid of a positive 1, do the opposite. Subtract 1 from both sides. Keep the equation balanced. So those go away and you're left with 4x equals 8. Last step, x is still not all by itself. That 4 is being multiplied to it. So to get rid of it, we're going to divide by 4. Both sides need to be divided by 4. So that turns into a 1x, or just x, equals 2. All right, and lastly, just two more equations. Now we've got division involved with the order, or with the two-step equations. If you notice, both of these equations have division, but they do look quite different, and they are going to be solved differently. So looking at the orange equation here, I see a constant. Well, first we want to do our line. I see a constant. I need to get rid of it because it's not with the x. So plus 2, the opposite is minus 2. And I'm left with x over 3 equals, once those 2's go away, 1 minus 2 is a negative 1. Okay, so if you remember back to the one-step equations, when you have division, x is being divided by 3. The opposite is multiplying by 3. So both sides I'm going to multiply by 3. Now you can wipe those 3's out, and you're left with just x equals negative 1 times 3 is a negative 3. All right, this green equation is probably the most complicated out of all of them. I have an expression in my numerator, not just an x or not just one number. I've got an expression x minus 4 in my numerator. All of it is being divided by 2. We want to get x all by itself by first moving any constants. Well, I see negative 4, but it is not by itself. It's got the 2 underneath it, so I can't get rid of it yet. What you want to do is eliminate any fractions that you can, and since there's only one fraction, this whole thing is a fraction. I'm going to get rid of that 2, which is dividing the top, by multiplying by 2. Again, I have to do both sides multiply by 2. Now, the x minus 4, anything in the numerator is considered in parentheses. So I could go ahead and distribute, but I don't want to do that because that'll overcomplicate things. If you remember, anytime you multiply something by a number that's also in your denominator, those can cancel. I don't need to touch the x minus 4, just bring it down now. X minus 4 equals 10. Don't mess with distributive property, just multiply by the number that's in the denominator. And then last step, minus 4, to undo it, do the opposite, add 4, and I'm left with x equals 14. So notice here, I'm going to use the highlighter real quick for you. Notice the difference between these two equations. I have this 3 over here that is only dividing the x. It's not touching the 2. But if you look over here, this 2 is touching all of the numerator x minus 4. They are done differently. On the left side, you need to remove the 2 first, and then you're going to use multiplication to get rid of the 3. On the right side, you need to multiply first to get rid of the denominator. Then you can just focus on the numerator's expression. All right, you're going to pause this video and complete the 4 problems that you're about to see on the screen. Once you're finished, play the video again and the answers will be revealed. So here are your 4 questions. And go ahead and pause it, write all these down, solve them, and then the answers will show once you press play again. Okay, here are the answers to your 4 1- and 2-step equations if you did it correctly.